There are a number of industrial collaborators in this work, but the whole word industry has a couple kinds of meanings. So one kind of collaborator is what you think of as traditional industry, where they have very demanding problems at the frontiers of fabrication. So we're working with Spirit Aerosystems, which was formerly Boeing's factories, and they make the 737s and 787, large parts of the fuselages. And we're working with them on these entirely new fabrication techniques. To build the 787 was a multi-billion-dollar investment, and it's not going to work for the generation of planes after that. So we're working with them on these high-performance materials as entirely new ways to make airplanes. Or in aerospace, Moog is the leading company for flight controls, and we can make these materials programmable and change shape. And so it's an entirely new way to think about how the materials perform. So we work with a number of companies like that that are sponsors of the research. But in addition, there's a very different sort of economic impact. And if you think about PCs versus mainframes, initially for the National Science Foundation, we started a very small outreach project where we started setting up community fab labs. These were field fabrication labs. And the way to understand those are, the facility I run at MIT has millions of dollars of tools, and the coming Star Trek replicator is a $100 atomic assembler that'll fit in your pocket. The fab lab is in between. It's equivalent to like the mini computer in the history of computing, about a $100,000 facility. It's much more than a 3D printer. It's a range of additive and subtractive tools and materials and components and workflows and software we developed that let you make functional things. And those have spread virally, kind of accidentally. There's now about, I think 150 of them. They're doubling every year and a half, of these high-tech, small-scale facilities spreading domestically and internationally around the world. And what's very interesting is they're being used as community resources for empowerment outreach. They're also being used for education, and they're being used to create businesses. But they're very different businesses, because with this infrastructure, you don't ship a product to go to market. You can ship data and then produce products on demand locally. And so design, purchase, and fabrication can all be distributed rather than a conventional model of you make a thing in a factory and send it. And so in the same way the internet was invented in the mini-computer era of computing. Computers got faster and simpler, but the notion of the internet came then. What we're finding in this Fab Lab project is sort of how you live, work, and play if anybody makes anything. You can do today with the tools. They'll get integrated. Today it's $100,000 and 10 different tools to cover the range of capabilities I'm describing, but you don't need to wait for the research to be finished. So along with working with existing companies through the Fab Lab project, we're collaborating on creating entirely new kinds of business models that have a very different profile of globally connected but locally integrated. Some of the interesting points in commercializing products through digital fabrication, but done in this distributed way. For example, there's a wonderful fab lab run by a collaborator in Barcelona, and he's now in charge of planning Barcelona's future. He's the city planner, the chief architect, and his friend, his colleague who co-founded the Fab Lab, is deputy mayor. And the connection is the city has 50% youth unemployment, but they buy products made far away that come in on ships. And so they're filling the city with Fab Labs, with these digital fabrication facilities, so it can be globally connected for knowledge, but self-sufficiently locally for technology, so you can produce the high-tech products that you consume. And recently, a colleague, Bill Foster, in the House, is preparing legislation in the US to take the whole network of these community labs and turn it into a national lab, where the idea is national labs today are billion-dollar facilities, but they have a hard time connecting to communities around them to impact business and education. And so Bill's legislation is taking the network of community labs and building a new kind of national lab out of linked local labs. So one of the surprising outcomes of this work is, even though the research we're doing in this project is digitizing fabrication, we're ending up spending a lot of time with governmental and non-governmental organizations and international development and business groups, because it really just fundamentally changes the whole notion of how business and development and education happens.